Okay, today we're going to be talking about the motion of a charged particle in an electric field. When we have an electric field, right, this is the direction of the electric field. Now, if we have this part of the electric field to be positive, electric field flows from positive to negative. So, if we now put a charge inside this electric field, like in the previous topic we said, if a charge is introduced into this electric field, it feels a force. And naturally, force makes an object to move. So if this is a positive charge, of course, it's going to repel this positive charge here. So it's going to face a direction, a force that moves in this direction. What if a negative charge is introduced into the field? If this is a negative charge, it's going to repel this negative charge. Any direction you put it, any position you put it, this is a negative charge. It repels negative charge and it feels a force that draws it towards the positive charge. So the force creates motion. It creates this tendency for this charge to move. And we know that force is equal to mass times acceleration. So this acceleration tells us the motion of this charge in this electric field. So when a charge is placed in an electric field, it feels a tendency to move, it feels motion. So if we relate this formula for force with the formula for, we remember I told you in the last topic that the electric field felt by a charge in an electric field. The electric field strength at a point E felt by a charge, if this is a charge introduced to this electric field, the electric field at this point is equal to the force felt by that charge divided by the charge. So we simply now say that the force can be converted into mass times acceleration. So this formula can be written this way. This should be another formula you should remember in this semester's physics electric field. So anytime you are asked a question in an examination to the question is relating the acceleration of a charged particle, the electric field, the mass. This is the formula that comes into mind. So let's just treat a question to understand this thing better. So we have a question like this. The question says an electron of mass. They give you the mass. Remember, they don't always give you the mass. You should know the mass of an electron is constant, 9.1 times 10 raised to 1 minus 31 kilogram. So an electron of mass is accelerated in uniform field of, they give you electric field between two parallel charged plates. You can just forget about every other details they give you in questions. Those details might just be to confuse you. You just need to concentrate on the key points. They give you mass, they give you electric field, then they are looking for the acceleration. So you now think which formula relates mass, electric field, and acceleration. And I believe the only formula is electric field, which is equals force over charge, can also be written as, let's just say, mass times acceleration over charge. So now, they don't always give you some constants. Like the mass of an electron, it was given in this question. It is not always given. Sometimes they just say an electron. So you need to know this. And also the charge of an electron might not be given. In this question, it's not actually given. It's a constant. The charge of an electron is 1.6 times 10 raised to the power of minus 19 coulombs. So to get the acceleration, we make A subject of formula. So making A subject of formula, I'm going to be quick about it. If you don't understand subject of formula, you just need to go for my maths class. So we have A equals EQ all over mass. So we impute the details. We say 2, the electric field is 2 times 10 raised to the power of 4 Newton per coulombs multiplied by the charge of an electron is 1.6 times 10 raised to the power of minus 19. Then divide by, let's say, the mass of an electron, 9.1 times 10 raised to the power of minus 31. So if we simplify this, I believe we're going to get something called something like 5.3 times 10 raised to the power of 15 meters per second squared. So you can solve the second example or look at the second example in the app. I believe this is what you need to know about the relationship between acceleration, mass, electric field, and charge. Oh, someone just corrected me. This is actually 3.5 times 10 raised to the power 15 meters per second. You know, my mouth was saying something else and my brain was thinking about food. But I guess we all know what I'm trying to say. So that's all for now.